Now, the last thing that we talked about, or that the lady talked about in the lesson, was solving polynomial inequalities. There's not an equal sign there. There's a greater than or a less than, greater than or equal to, less than or equal to. These, we got to write the range where the numbers fit, okay? So solving something like this, what we're going to do is we're just going to sketch this thing like it's a regular polynomial first. So because it's an odd and the leading coefficient's a positive, we know that the picture of this is going to be up on the right, down on the left. And the x-intercepts are going to be at a positive 3, positive 1, and negative 4. So the end behavior says here and there. Okay? We just got to figure out if it's connected above or below here. Is it a, so pick a number. If you pick a number 0 and plug it in right there. When you plug in 0, you get 0 minus 3, 0 plus 4, 0 minus 1. That's negative 3 times 4 times negative 1 is a positive 12. That means that this thing connects way up here at a positive 12 and goes through there. Now pick a number between there, like a positive 2. That'd be 2 minus 3, 2 plus 4, 2 minus 1. That'd be negative 1 times 6 times 1, which is a negative 6. That means these things connect like that. So the picture we've already learned how to do. Hopefully you've gotten a little practice drawing these things. This is the picture of that polynomial. To find out where it's greater than or equal to 0, if it's got that dash or doesn't have that dash, all it's going to do is decide if you include these x-intercepts, okay? All I've got to do is decide, since it's greater than, is where is it above the axis? It's above the axis here. It's above the axis out here. Notice this problem doesn't have anything to do with a y. It is only wants the answers for the x's. So here's what we're doing. For our problem, we're going to choose the x's between here and here. Well, that's negative 4, and that's a positive 1. So we know between negative 4 and a positive 1, and since it's or equals to, include those boundary points, that section, all the x's between here, give you a positive or bigger than 0. Over here, that's from 3 to infinity, because remember that goes up forever as long as it keeps going to the right. So this is going to be positive, so that's union 3 to infinity. Infinity always gets a parentheses, but that 3 gets a bracket because this problem has an or equals to on it. This is my answer right here. It is the problems from negative 4 to 1, 3 to infinity. Now the only things that would change on this problem if that symbol's different. For instance, if they give you x minus 3, x plus 4, and x minus 1 is less than or equal to 0, if they gave you that problem, well, the picture is still the same. They just want the parts that are below the y-axis. So that would be this section. That's from negative 4 back. That would be negative infinity to negative 4. Union with this part that's below there. That's from 1 to 3. So that would be the answer for the problem if that were the question. And the only things that would change if this was the next problem, if that was the problem, notice it's almost identical to the first problem, right? Except it doesn't have the or equals to. It'd be this exact answer, negative 4 to 1, union with 3 to infinity, except they use parentheses only because it's not or equals to, means you can't use those endpoints.